Hello everyone, welcome to the channel. In this video, we will see work done by spring force. Okay, so here we are going to see work done by spring force. So now, what is spring? So we all know spring is nothing but a mechanical component. Okay, so it is used to stretch or compress. Okay, so here if you see, just imagine this is your spring. Okay, this is a spring. It is nothing but a initial one, or else I can say it is a free length or else original length of the spring. The length of the spring is original, or else we can call it as a undeformed spring, undeformed length as well. So in question you can have this many words. Whenever we have a free, original, undeformed, that means the initial length of the spring. Okay, free length or else original length or else undeformed length. Okay, now just imagine if I'm using some force to stretch this spring. I'm using some force to stretch this spring. Okay, so now the deformed shape, I'm using a word called deformed. Initially it was undeformed, now it has been deformed. Okay, so that means the length of the spring has been deformed. Now it is a deformed length, right? So here this force which I applied, that is the spring force, spring force. So whenever you have a undeformed length of the spring, at initial condition you required a lot of force to deform that spring. After certain distance, again you will require less amount of force. That means here the force applied at the initial and after some distance, when it's moving on distance, the force has been decreasing. That means for every displacement the force has been changing. Okay, so the spring force will be equal to minus of k into x. So here k is nothing but the stiffness of spring. Okay, k is nothing but stiffness of spring, and x is nothing but the deformation. X is nothing but the deformation of spring. So deformation, how x is been calculated? Now just imagine, initially the undeformed length of the spring was something 10 meter, imagine, and now the deformed meter is something 15 meter. Now here the x has been, okay, now it has been deformed, right? So if higher minus lower, that is it has been deformed to 5 meter. The x has been deformed to 5 meter. You have to take the difference between the undeformed and the deformed. Okay, so this minus indicates that you are at the initial we are just giving some force to deform that. That is the reason we are using minus. So here the spring force is equal to minus k into x. So k is nothing but the stiffness of the spring, x is nothing but the deformation of the spring. Okay, so minus indicates indicate direction of the spring, indicate direction of the spring force. Direction of the spring force acts towards the original position or the initial position. Okay, original position. So spring force equal to minus k into x. Now we have to find work done by spring force. So now we know that work done equal to force into distance, right? So work done is equal to force into distance, or else displacement, or else change in displacement. Right, now this can be written as force into change in displacement as well. I can write delta x or else dx. So everything is nothing but similar. Dx is nothing but change in displacement, change in distance as well. So now we are talking about work done by spring force. So here this will be replaced by spring force. So work done will be equal to spring force. So spring force into change in distance, right? So we know that just now we found out the work done, spring force is equal to minus into k into x. Okay, so this will be dx. Now we have to do the integration. Why we are doing integration? Because as I mentioned earlier that we are applying force, the force will be varying with respect to the displacement. Okay, for every displacement the force will be changing. That is the reason we have to find the sum of those things. So for finding the summation we can use the integration. Now here we have two position, one is the initial and the final, that is x1, and the final will be x2. So minus of k into x dx. So k is nothing but the constant, minus k will become outside, x1, x2, initial, final, and x dx. The integration of x is nothing but x square. Sorry, integration of x is nothing but x square divided by 2. So minus k x1 minus x2. Okay. So this will be minus half into k into, if you apply the limit, upper limit minus the lower limit. Okay, since the minus is outside, I'm going to multiply the minus inside as well. Okay, so you can write down till here as well, no, not an issue. The work done by the spring force will be equal to minus of k into x square x2 square minus x1 square. This is also not an issue. You can keep it your formula till here as well. Or if you want to simplify further, what you can do is work done will be equal to, you can just multiply this minus inside. So half into k into, if you multiply, so x1 square minus x2 square. You can keep this formula as well. So you can take any two formulas. But if you are using minus outside, it will be change in the displacement, that is x2 square minus x1 square. If you are keeping a positive value, then it will be x1 square minus x2 square. So this is the work done by spring force. So the work done by spring force is equal to half into k into x1 square minus x2 square. So x1 is nothing but the initial position, x2 is nothing but the final position. Okay, so in the next video we will see a problem on work done by spring force. I hope you understood this derivation of the work done by spring force. Thank you for watching.